Algebra in GCSE level is quite straightforward. Most of the equations that you manipulate have just 3 terms. But there are some that you manipulate at GCSE level with more terms. Even things like half mv squared is a little bit more complicated. Or v squared equals u squared plus 2as. It's a little bit more complicated. So at A level, it's assumed that you are fluent in algebra. A lot of this you're going to know, of course, but I do see students every year who try to use these formula triangles, these dastardly formula triangles, to solve their algebraic issues. It wasn't good enough for GCSE level. It's definitely not good enough for A level. So we do need to forget about crutches like that and learn to use algebra properly. Now, it's not too tricky. Just remember what the equal sign means. Of course, the equal sign means the same. But it's not just the magnitude that's the same on both sides of the equal sign. It's also the direction, the dimensionality. Importantly, the equal sign doesn't just mean, and here is the answer. That's what primary school children often think. They write an algebraic problem, maybe they write 6 times 4, and then they'll put an equal sign, and in their head the equal sign indicates the answer is. That's not what equals means. It does mean it's the same on both sides. So you could do maths on both sides simultaneously. And whatever you do to one side, you must also do to the other side. But you need to know the order that operations are performed in order to get it right. So there's a few different mnemonics to help people remember this. I'm not a fan of mnemonics. I think that they are all crutches, and some of them are helpful maybe in the early days, but you need to really internalize some of this stuff. So the first priority is always what's inside parentheses or brackets. My problem with this is that when people learn a mnemonic, they think anything to do with brackets comes first. It's only what's inside brackets that comes first. You're multiplying something by a bracket, what's inside the bracket has to be handled first. The second priority is any powers, and there's so many words that mean the same thing. Powers, orders, logarithms, exponents, indices. The singular of indices, the singular is index, not indice, which I've heard before. Third priority, multiplications and divisions. I mean, division is just multiplication with a negative exponent. So they're the same priority. Neither has more priority than the other. The fourth priority is additions and subtractions. Remember, subtraction is just adding a negative number, so they're equal priority there. And you might have heard of PIMDAS or POMDAS or PODMAS or PEMDAS, or my personal favourite, which is 𝗶𝗶𝗶𝗶𝗶. 𝗶𝗶𝗶𝗶𝗶 is parentheses, powers, products, portions, pluses and purges. That's my favourite one. And it just shows how pointless these mnemonics are, because 𝗶𝗶𝗶𝗶 doesn't really tell you very much. So let's have a look at this problem. You can't do algebra if you don't understand order of operators. Here I've got 9 plus 2 times 4. Now, some people will be shouting at the screen saying, "Sir, it is 40." Others will be saying, "No, sir, it is 17." Some people will even be reaching for their calculator as though their calculator knows better. Calculators do make mistakes, and calculators do often disagree with each other. I am quite a fan of calculators. I have my own collection of them. They do behave differently depending on the calculator you pick up. So, what is the convention? Well, the convention is that we do our products first. So our product, 2 times 4, is 8. We can rewrite 9 plus 2 times 4 as 9 plus 8, which is 17. So there is only one correct answer to that, 17. That's if we're following the accepted standards for mathematics, which why wouldn't we? So here's another one, 10 times 2 divided by 4. Some people will be shouting at their screen, saying it's 5. Some people will be shouting at their screen, saying it's 20. Have take a moment to decide for yourself. Is it 5 or 20? Again, there is a correct answer. But in this situation, because multiplication and division have the same priority, it's not a case of multiplication comes first or division. You know, if you do PEMDAS, the M comes before the D. But if you do PEDMAS, the D comes before the M. So you're going to get people saying, well, you should do division first or you should do multiplication first. No, they're the same priority. So where you have two operators of equal precedence, you work from left to right. So first of all, we're going to do 10 times 2, which is 20. Then we're going to divide it by 4 to get 5. Now, what's nice is that some calculators are going to do this. You type something in, and it will shove some brackets in for you or something to try to help you. And the classic example, as you can see here, is when you use implicit multiplication. That is to say, I've put two quantities next to each other with no operator between them, and multiplication is implied. We do have to be careful of doing this because sometimes brackets aren't used in this way. If you're working with functions, for example, f open bracket and then a bunch of letters, then close bracket, what's in the brackets there are the variables of that function. They're not multiplied by that function. So the notation of brackets we have to be careful with. This one did the rounds on the internet a few years ago because different models of the same brand of calculator, different models of Casio calculators gave two different answers. If you typed in exactly as it said, they would appear exactly the same on the screen. 9 divided by 3, open bracket, 2 plus, well, 1 plus 2, close bracket, equals, and one calculator would give you a 9 and another calculator would give you a 1. Well, there is actually a correct answer. The correct answer for this one is 9, because you're working from left to right. And so 9 divided by 3, that's 3. Then that is multiplied by, okay, that's the implicit multiplication, that's multiplied by this thing. Remember, you do what's inside the bracket. Just having a bracket doesn't mean you do it first. You do what's inside the bracket first, which is 1 plus 2. So this bracket is 3, so you've got 9 divided by 3 times 3. Well, if I take 9, I divide it by 3, then I times it by 3, I've got 9 again. It's the same thing. If you wanted it to be 1, if you wanted this implicit multiplication here to be done before that division, you'd have to chuck some extra brackets, and it's that some modern calculators will do for you. If you enter something with ambiguous notation, it will change what you've entered. You do have to check back and see whether the calculator has interpreted your input as you intended it. Don't assume that the calculator can read your mind. They're very clever things, but they cannot do that. So that's in terms of using calculators and order of operations. Actually, using the calculator causes students to lose a lot of marks. It's one of the biggest causes of lost marks in, I'm an examiner, as I often say. It's one of the biggest causes of lost marks is students not really understanding how their calculator performs operations, what order it does it, and how it's going to calculate something. Well, if your calculator's doing things differently, how do you know what you're going to get out? How do you know that the calculator is working for you? That's terrifying. The idea of having a calculator where you type in an expression and you don't know if what it's told you is the answer to what you wanted it to tell you or if it's interpreted your input incorrectly. So here's a solution, a nice easy solution. Break a big formula into steps and do those intermediate calculations. Always do a quick check to see what you expect the answer to be and see whether the answer the calculator gives you is reasonable, even if it's just a quick order of magnitude check. Finally, in extreme case, if you're having problems because your calculator keeps on disagreeing with what you want it to do, well, get a different calculator. Now, I found this out very late in my physics career, that calculators kept giving me the wrong answer. My brain doesn't work like that. Actually, reverse Polish notation, RPN, worked for me. And I found a few students, not many actually, but a few students in my career who have picked up RPN and gone, actually, yes, this is better. This works for me. So don't be afraid to stand out and be different. You don't have to use the same calculator as everyone else. Caveat on that is when you get to university, You might have to, depending on the university. Some of them have strict rules about calculators that can and can't be used. If you're doing an apprenticeship, you're probably not going to use a calculator at all. You're going to use spreadsheets and Python or something like that. You're not going to use calculators. So, we want to make a variable the subject. What do? We perform the opposite operation on that whole equation to what's being done to that variable. If there's more than one operation that's being done, we need to unravel them. We need to do them in reverse order, which is why it's important to know the orders inside and out. So here's an example for example. That's good. We want to make x the subject. We have this expression, 22 equals 4 times x plus 2. Well, in terms of operations, in order to get 22, we had to first multiply 4 by x, and then we had to add 2, because 2 comes, the addition of 2, comes later in the order of precedence than the multiplication between x and 4. You add 2 at the end. Not just because it's drawn to the right on this picture, but because pluses comes after products in the mnemonic. So what are we going to do? Well, first of all, we're going to do the opposite from the last thing that was done to our variable. Our variable was times by 4, and then it had 2 added to it. So we subtract 2 from both sides. 22 subtract 2 becomes 20, and all of this subtract 2 just becomes 4 times x. Now, what's the opposite of multiplying x by 4? Is dividing by 4. So we do that to both sides to get 5x. In the early days of doing algebra, you really do want to lay out all of those steps. It is important. Now, things to bear in mind with fractions. Okay, you don't want to embarrass yourself in front of your class by not realizing this, but I do see it all the time. 10 times 5 divided by 2 is the same as 10 divided by 2 times 5 is the same as 10 times 5 divided by 2. It has to be. Because what does divided by 2 mean? It means that division symbol and then the 2. And you could put that anywhere. It doesn't matter because multiplication and division have equal precedence. So it doesn't matter where you put it. So all of these three are actually the same. You don't have to believe me. You can check it for yourself. They're all equal to 25. 10 times 5 is 50. Divided by 2, 25. 10 divided by 2 is 5 times 5, 25. 10 times 2 divided by 5 divided by 2, sorry. 5 divided by 2 is 2.5 times by 10. That's 25 again. They're all 25. So, one way of dealing with this is to use negative powers and multiplications. And you can see it doesn't matter which order you put this in. That's one way around it. Another way around it is to get busy with the brackets. Use a lot of brackets. Don't do fractions of fractions if you can help it. So here you can see 200 divided by 20 divided by 2, or alternative, 200 divided by 20 divided by 2. Well, they sound almost the same. Indeed, they look almost the same. If you've got a very keen eye, you'll spot that this 200 divided by 20, the division is slightly shorter than the one beneath it. Whereas this, the division here is slightly longer than the one beneath it. But in handwriting, that can be very difficult to spot, especially in the heat of an exam. So let's get out the habit of doing that. If you chuck some brackets on this to see how it should be interpreted, you'll see you get two very different numbers. You've got to be careful. Another alternative way of dealing with that is to use your negative powers. If you intended 200 divided by 20 first, and then divided by 2, that's this. 200 divided by 20 divided by 2. In fact, you can do that in any order, and that would give you 5. But if you intended 200 divided by half of 20, 20 divided by 2, then you could do this. It's a bit of a mess, of course, but you could do this. You've got your 20 here on the bottom, and then you've got this 2, which is a denominator, but it's a denominator of a denominator, so there's still a negative 1 power there. And that gives you 20. Or alternatively, you could have put the 20 divided by 2 all within a bracket. And so this is 20 times the reciprocal of 2, that's 20 divided by 2, and all of that is on a denominator, so to the power of -1. And all of these expressions mean the same thing, they mean 20. So a bit of a summary of inverse functions, here they are. Opposite of multiplication is division, opposite of addition is subtraction. We've got here powers. The inverse of a power a power is a root, so the second power, or squaring something, the inverse is a second root, or a square root. And there's another way of writing that, which is a fractional power. A square root is a power of a half. A cube root is a power of a third. That's another way of writing them. We also have your trig functions and their inverses: sine, cosine, tangent, arcsine, arccosine, arctangent. And your calculators may say sine to the -1, but that's an ambiguous notation, so I avoid it. So the power of -1 means the reciprocal. It can mean the inverse as well, but it's because of that ambiguity that if I can avoid ambiguity, I will. And that's a good habit to get into. So I always write arcsine, arccosine, arctan instead of using the -1 notation. My favourite calculators just say ASN for arcsine, ACS for arccosine, and ATN for arctan. They don't use the -1 notation. And finally, one at the bottom here, which we'll have to go into in a little bit, is logarithms. N to the power of A equals B is actually the inverse of log to the base, bad wording, log with a base n of B is equal to A. Those two actually mean the same thing, but we'll need to handle logarithms separately. So in the meantime, you can practice your algebra. Hopefully this link is still live. Hopefully this page of Isaac Physics questions still exists. If it doesn't, you can find those Isaac Physics questions or other questions that you can use to practice algebra. Wolfram Alpha, for example, has a wonderful worksheet creator that you can use to just practice algebraic manipulation.